Good afternoon, everyone. Welcome to our Better Builds Prep webinar. My name is Adinda, for those who don't know. I recently started working for AMIS, and I'll be responsible for customer support and software testing. And today I'm joined by my colleague Chris and our guest speaker Ludwig from Phasio. And also our audience is quite an interesting mix today. We have SLS users and MGF users present today, and we also have a mix of print service bureaus as well as end users here. So we think that that will make up for quite an interesting conversation. Before we get into the presentation today, I quickly want to say that there will be a Q&A. And so you can leave your questions in the chat here during the presentation, and I will gladly answer them afterwards. So without further ado, I'll give the floor to you, Chris.
Right. Thanks, Adinda, for this short introduction. And me too, I'll try and be brief. Meaning I will try not to spend too much time on going over all the different features inside AMIS Pro, but instead I will try to make much more time giving you a bit of a demo on how to do better build prep with AMIS Pro. I think that's more important. That's rather than focusing on features, I think we really should be talking about how can those people in your organization responsible for the build prep, for the nesting, how can they be able to make better builds, meaning to put more parts inside builds, quality parts, of course, because they can really make a difference for your organization with that. And with 3, 5, or 7% extra material inside a build, that's really making your business case. And so that's what I want to focus on today. And yes, we'll go through the features and the newest features in our latest release 252. But mainly we will look at this demo, and I'm not even alone with that, apart from the demo on the AMIS Pro software and the nesting itself. We also have Ludwig Handel from Phasio here, who will, briefly highlight what Phasio is about and how it connects with AMIS. And we think that's a very important evolution that we're going through here, because basically it means that with this kind of combination of software, your nesting is not a standalone process, or your build prep is not a standalone process, but really becomes integrated with your workflow. And that's something we realized, and then in a very friendly and amicable way with the guys from Phasio. So we were glad to invite them here to demonstrate that. Apart from that, we'll also be having a look at the pricing of AMIS Pro. That won't take long, it's not that difficult. And we'll try and have some time for your questions and answers too. But as Adinda already indicated, please do feel free to already post questions during the presentation. Perhaps there's already a couple of things we can pick up on during the session itself. But so back to this initial focus, or the main focus of today, this better build prep, this possibility for your organization to actually make more out of each build that you're printing. Now, we don't see this as a one-off. We don't see this as a button, a number of tools, and then a button to say nest and ready, and that's it. We really think that in most cases, it's an iterative process whereby you will increase each time you're nesting so as to come to the most or the fullest nest, fullest for what is possible for those parts, for those materials, for those printers, so that you actually get the best cost per part out of these parts. Because, and as I mentioned already, it is a complex matter. It is not just one algorithm that can be perfect for each machine, for each material, for each type of parts, of size of parts. So you really have a lot of options within Amos Pro. And what we mainly want to demonstrate you is how do you get the most out of that? What are a few tips and tricks to actually make that work better, to have a better opportunities there? But before we go into that, as promised, I will take you through the features a little bit one by one, but we will not waste too much time on that. And by the way, when it comes to what already exists in Amos Pro, you can always find that back on our YouTube channel. With a lot of tutorials there and also the previous webinars. So you can always look up things there in detail too. But on those features and basically answering the question, why are we doing this? Why do you need those tools? What do we want to achieve, and what are the main reasons for us to actually make Amos Pro as it is now and to continue building in it in the same way? Well, first, we want you to be able to put more parts in each build. We want you to have less risk, meaning less broken parts or disrupted parts. We want to offer you support. We want to offer you scalable support and scaling support. Adinda is now here, part of the team. She's already part of our scaling support team. And also we want you to spend less time and less costs on your build preparation. It should be a smooth operation. It shouldn't take you half a day to prepare a build. We think it should really go faster. And for that, we also try and spend a lot of attention on the user experience, on the ease of use of our solution. Now, this why all comes for us related to the cost per part, and people who have followed the previous webinar know this overview already. All these themes are for us connected to cost per part. It's about quality, because a part that is broken is also a cost to your organization. So even quality is in that sense connected to your cost per part. So what did we put in up to now? That's first of all, and I think we're quite known for that one, is the nesting speed within Amos Pro, which is unseen so far. We put in higher densities. Quite often we reach the highest densities there is for certain packagings. We have a high ease of use. We have no interlockings, which are possible. I had to create this two interlocking parts manually because it was not possible in Amos Pro. And we want to offer you decent support. For that, we want to offer you more tools, and that list of tools is always growing. We have the configurable boxing now, just as well as the shelling, the nesting. We have a very easy recovery function, just to make it possible for you when a print would fail, let's say halfway, that you can easily recover the parts that need to be reprinted, and you're just in seconds, you're on the road again to having the next build printed. You can now lock and unlock parts, which as such may not sound like a big thing, but you will notice in the demos, it's really an important tool to play with, to allow you to have different options in your nestings. We have also more options when it comes to rotation. So of course you can rotate your parts, and now also with a gizmo, by the way, but also you can allow certain rotations in X, Y, Z on a per part basis and on a per batch basis, etc., because the list goes on, of course, with the possibility to prioritize parts, to select multiple printers now, to have STL or 3MF exports, but just as well the slices, also 3MF slice export, by the way, as well as TIFF and SVGs. The part list export has been expanded, and we have the unplaced function and the recover function, as I said, which really makes it possible inside Amos Pro already to have a sequential batching, sequential nesting as you go through the through your work for the day, let's say, or through your prints for the day. And last but not least on that list is indeed the Phasio integration, which will be highlighted by Ludwig a bit later from now. Another one, which was already known, of course, to most of you, is the possibility to actually what we call have a nest to density, so that you really say like, okay, my density inside my nesting can only be or should be topped off at, let's say here 13%, which makes it really possible to manage this heat or this binder spreading inside your build, so which really improves your quality or of your outcome of your builds. And then when it comes to the version 252, the one we actually just released this week, and you can always contact us for a trial license, obviously, there's a couple of things that are new in there as well. First of all, the fact that you now have the part manipulation through a gizmo, making it not only easier to see how you're rotating the part and what you are actually rotating, let's say, but it also allows you to rotate in steps, for example, 15-degree steps or 30-degree steps, whichever you choose, you can adjust it as you like it. We got the direct HP MGF slicing coming up. The connection is there. We've already tested that successfully. The slicing itself is well, as such, it's there, but we're collaborating as we speak with HP to have it vetted by them as well, so that we're absolutely certain that what the slices that come out really match the slices that are expected by the different MGF machines. We now have also the CAM spec import, and we can export to Phasio. The CAM spec import was a necessity, of course, in order to have this integration with Phasio getting started. It's a very interesting file format. It's freely available, by the way. You can just look it up and start using it yourself, because basically it allows you not only to store your parts inside, the quantity of the parts, but also other restrictions related to that part. If, for example, the rotation or the position of the part, etc., which of course, in terms of nesting and batching, comes then as a memory of what you've batched before or of how you want it to be batched, nested in your print. So you can see that there's a lot of advantage there coming up with that collaboration. We also have an installer now, making it much easier to actually install Amos Pro on your computers or laptops. And you can set the voxel size for nesting. Now, that's something which I'm not showing today. If you want more details on that, it's a bit of an advanced level option. But basically, it again comes down to this, that when people contact us and they say like, oh, this batch isn't working so well, we're trying to have a decent density on this batch or a decent nesting for this batch, and it doesn't seem to work too well. Luckily, people don't come and say us like, okay, Amos Pro isn't good. They come to us and say like, hey, this doesn't work so well. And that's very good, because basically it comes down to having access to this knowledge of how you can indeed improve your nesting, so that and to now we've always been able to do so, to actually go beyond results of any competing software. So there we're, I think, very strong in giving you the options, but quite often it's a matter of knowing where to find them, and that's of course why we have this session today. What's also still new in our latest release, that's the possibility to select multiple parts at a time, which, well, again, looks like something quite small, but it makes a huge difference when it comes to rotating multiple parts at the same time. Definitely when you're, for example, specialized into insoles or dental parts or such things, which are quite often needing a similar rotation inside your batch. The multicolor is also now fully operational. So if you're still printing on an HP 580 and the multicolor, you should be able to do that without any issue. We've got improved file healing. We got disallowed access rotations, not only on a per part basis, but also on a per batch basis. I'm saying this very quickly, but perhaps not everybody knows what this is. It means that you can tell the algorithm that it is allowed to rotate parts over certain axes while nesting, either on a per part basis. So maybe part A, yes, you can rotate, and part B, no, you can't. But then you can just as well do that on a per batch basis and say okay, for this entire batch, everything inside this batch, rotation over the Z-axis is allowed. And it makes it, of course, much faster to, apologies, um, to make that possible to quickly allow for these rotations. And well, another one which might seem small but makes it again quite a bit easier is that you can set a limit to the nest height, which of course, and that's more and more, we see it more and more coming in reality. That's very interesting for printing half batches, whereby there's a night batch and a shorter day batch which is being printed. So then you can just enter the allowed height to which can be nested, so that you can actually create a batch which is printable in the time frame that you actually have. Apologies for that. We're also making steps into automation, and there's a few companies that were already looking into this, I would say, quite deeply, whereby you can, well, the basic idea is record and replay. So you record a certain sequence of nesting, and you can replay it. So you can kind of build a script on how to nest a certain batch. You can even compare then the files, the outcomes, if you would want to do that. But it basically means that it will allow companies in the longer run to start looking at building scripts on their own for certain, so as to automate certain nestings. Because of course there will always be cases whereby it's more interesting to do it manually and to still return to what we actually know, or what is actually yeah, this fine tuning can still, of course, add value, because the adding value is what we're talking about today. Well, so as promised, there was a very short run through most of the features that are installed today into AMIS Pro, and I think it's much more important now for everyone that we really go further into the demo. And what we prepared here is basically 3 cases, only 3 cases, but I think they demonstrate quite well where your options may be in playing with the different options that you have or that are available inside AMIS Pro. So let's start with the first one, and I will just create a new, no, I won't create a new batch, excuse me. I will open a batch. Let's see, the one for today, and that's a cam spec. When it's a cam spec, that tells me that it immediately, as I said before, will have not only the parts inside, but also their rotations. So if I look at this part, this was pre-rotated. This one was also pre-rotated. This one also. So the rotations are already in there. Somebody decided on the rotations prior to this process, so to say, or they were saved somewhere. So that's also saved inside, and also the quantities. So you don't have to enter the quantities here anymore. Again, taking away some possible mistakes and just typing errors that you might have there. Now, and then of course, this is the kind of video we love to show to people. There it is. This was the nesting by AMIS in 5 or 6 seconds, which of course doesn't necessarily lead to your perfect batch. And I think that's important. The speed, however, allows us to start iterating and allows us to really start working on this build so that it becomes the batch that we want to print. The batch that we trust will result in a good quality, in high quality, in non-broken or warped parts or things like that. So let's just go through a few options here already. First of all, we can go have a look at the densities. And then you see that we're having here a peak up to 38% nesting density. And for some technologies, that's going to be slightly too high, let's say, or way too high is maybe a better way of saying it. Now, a big part of the problem is probably these three big parts here. I will double click so I get into the part view, which are not hollow. And let's assume that the customer doesn't want us to hollow them out, because of course we do have the option to foresee a shelling and a lattice inside, but let's assume the customer doesn't want that actually in. So they of course cause quite some density peaks at certain heights. Now, one way of going about this, and the most powerful way probably, is this max layer density that I mentioned before. The max layer density, which limits the density for each layer in the z-axis to a percentage that you can decide on. Let's first put it very low just to see what the result will be here. Right, there you are. And there you immediately see the challenge with this one. The max layer density, it's a very powerful option, because indeed now you will see that the density will be much more in line with what you would like to see for your print technologies. But on the other hand, it logically starts from the middle, because if it would start from the side and you cannot know exactly how much percentage you will use over that layer, you might end up with a very spread out build. So that's perhaps also not ideal. So this algorithm starts from working from within the middle. Now, and it also starts quite often with the biggest parts first, because quite a lot of our users actually tell us that they prefer to put the bigger parts in the middle of their build. So that's the logic behind it, and it's important, I think, to understand that logic. Now, but this is not an ideal build, because we're losing a lot of space here. Whereas on the other hand, okay, we're happy with the density, but we're not fully ideally using our space. So one option here could be, for example, to say like, okay, I'm going to pull this one up. I'm going to go to the part and I'm going to lock its position. By the way, I'm totally not worried about the interlockings here or anything, because that will be solved as soon as as we renest again. This one I'm also going to lock here in position, and this third one, which is again so very bulky, I will put it up also. Where was the other one? And I will lock it. And now, of course, I'm losing a bit of sight. Am I not interlocking parts myself and then locking them so that they are interlocked? Because that's a possibility, of course, and that would be a danger. But for that, there is also a very easy solution. You just clear the nesting, and then everything will be thrown out except those parts that you have manually moved. And then you get a good view on, okay, they're not touching, they're actually not having, or giving any collisions there. But I do notice that I put those two on the same height, which is a bit, not exactly what I intended to do, because I did want to play a bit more with the density actually. So I'll put this one again a bit lower. Now let's renest that again. There we are. This is already getting a bit closer to what we want. We're now at a nesting density of 10.47%, with a height of 368 millimeters. And there is one very important thing I can still say at that moment. You've probably noticed already, but people who are new to Amos Pro don't always realize. When I nest, I never wait for this figure to become 100%. except maybe with the very last nesting, when I think like, okay, now it's really vital. It can take a while. I anyway have time. There's no specific deadline. Then you can just let it run because it will keep on looking for iterations or possibilities that might just be a bit better than the previous one. But as we're now just working through the logic of getting this better built, that's too much detail. We just have to wait for the 98% or 99%, and we can move forward. And that really allows us to work very quickly. So this one is already a bit better spread out than before. And I'm just gonna have a look here at this 10.47. Let's say this is the maximum that we want to reach. And let's assume that. But why not spread out everything a bit more? Then we have a more nicely spread build, so probably higher quality build. So we can perhaps just increase here the gap distance and see what the result would be at that moment with that same kind of result. Right. Well, we're actually ending up at 10.48%, so with the same height. So that there is no difference. So we can just as well go for this result, and everything is more spread out. So that's basically a more optimal result. We could still start shifting some parts a bit up or down if we want to, but basically, if we purely look at the density information, this is quite a good build normally. So from this first example, what I wanted to demonstrate was like, okay, density is not everything. Density is important, of course, but not all technologies can go sky high in density. So you might have to limit that. And then when you limit it, the bulky parts can really become a big player in your in how your density is divided and how that affects the rest of your build. So playing there with, for example, the densities on one hand, but on the other hand, with the location of the parts, so locking their locations really might make a difference. By the way, I didn't yet touch this one here, the allowed rotations, and let's say I will allow rotation in all directions for all parts in one direction, the z-axis. That might further increase, well, that will probably further increase the density of my nesting and the quality of my nesting. So I might want to try that. But of course, it exponentially increases the amount of possibilities. So there you might have to be prepared for some waiting. And that's why quite often we also advise to keep this for the last. We're already at 98%, but it will probably keep on iterating quite a while because it keeps on finding other opportunities, of course. So quite often this allowed rotation is something to keep for the last. Right. So that was case number one. Let's say we're printing that. And let's now just start with a next batch. Discard this one. I'm gonna make an HP printer with PA12 inside. Let's create that, and then let's put some part in there, and then what's today's second case? Insoles. I'm taking insoles because it's a very interesting case on which we've been working quite a bit. Insoles are in a sense quite easy because they're quite flat. They can usually fit quite nicely next to each other. But then again, you have these cases whereby they don't fit nicely together, but perfectly fit if you twist them around like that. If you give them a 90-degree twist, and then they fit perfectly next to the other one. But that's also not always the case. So it's quite often a case where it's really worth looking at different options. Now, first of all, what I'm going to do, because this is not the print direction I would like to use for these insoles, is actually I'm going to rotate them 90 degrees over this y-axis in this case. I use the old shortcuts, Alt Y, to rotate them all at the same time. And then, as we quite often do, just give it a first nest. Shouldn't take too long, so that you already have a bit of an idea of what it could look like. Well, there we are, 98%. This is actually well, not that bad, I would say, for a start, with a gap distance of my 5 millimeter. This shouldn't be too bad, but of course you can see it's these are thingiverse insoles. It's very hard to get real people's insoles, as they, of course, are protected. We understand that, but this already works quite well. Now, in many cases, as I said before, it can be a very good idea to say, like, okay, let me select just half of the parts. Now I just clicked here, half of the parts, approximately half, and let's start rotating them around. And in this case, it's not gonna give us a big difference. Parts, nests, nest. There I go, because they are so flat and because they have really the same size. But in some cases where they're a bit more rounded, or half soles or things like that, or they're just a bit shorter and fit more nicely inside the build box, it really can be that they are basically nicely matching one to the other inside that build box. And that, of course, can make then a huge difference in how many parts you actually get inside your build box. Now, you would say, like, what you just did now with rotating half of the parts, isn't that exactly the same as saying, like, okay, you can apply this to all parts? And in a sense it is, of course, because basically you're just checking options. Only when you allow more rotations to the parts here in the algorithm, you should just be prepared to have a longer wait, because of course it's going to check every possibility for every insole, whereas when we pre-arranged them, the possibility that they actually would fit was much higher, and then we immediately have a solution for all of them. So that's a two different things you can play with quite different possibilities. Now, in the same sense, and I'm gonna add a few more parts here. Well, just a few more of the same. There we go. In the same sense, you could say, like, okay, I can try to fit those 4 new insoles still inside, and then I'm gonna give the algorithm quite a job to figure out how it can fit it inside that batch. Whereas, of course, if you're having a bit of an eye on this, you already notice that we still have quite some space here. So why don't we try something else and just take those 4 parts, rotate them, and oh, that was not what I intended. It's like this. Right, so they're ready to be imported. Now what I'm going to do first is I'm going to lock all parts, because let's say I'm happy with this arrangement already. So I lock them all, so these won't be touched anymore with the next nesting. And now I nest, and it's going to put in these 4. And of course, it's going to very quickly find a solution to place them, because they were already prearranged. The algorithm would find it also, but it would take you longer, of course, because it needs to check all the opportunities or all the possibilities in there. So those are really ways to not only work up to higher densities, put more parts inside, but also to work in a quicker way. And I think it's vital. Something called something very modern. I think there is artificial intelligence, but now there's also something called human intelligence. And I think it really helps if you're doing this build prep. So, but it's really a matter of learning to play with that. Imagine that we had just one too many here. That's also perhaps important to say. I'm gonna unlock first, so otherwise I can't move it. And imagine we had just one sticking out here, and that's basically totally ruining my nesting density at that point. What I could then still do is just put that one out. Oh, that was a bit too far. Again, lock all, and then this one is still free floating, so that again can be nested inside separately. Of course, now it goes back into the same place, but it might then also allow you to again say, okay, let's rotate this one, and here I'm gonna again use the Alt button to shift by 90 degrees, by 15 degrees at a time. Right, and then I expect it to be, yes, indeed, right there in between. So it's this combination, it's this play which makes it possible to reach the higher nesting densities and still have possibilities. We know really from experience that insoles can be challenging, but also can really make a difference. If you can put in, let's say, 6% more insoles inside one batch, and if you're running one or two batches a day, 200 or 250 a year or something like that, you can imagine what an impact that has on your cost per part, on your actual gains from printing. So it is vital to really go to the core here. And you should also know that we're always glad to help. I mean, if you come with a case like this and you say like, oh, we think it should fit more, it's it keeps us more busy than Netflix at night. So it's just fun to go look for the best solution together with you. Third case, and this is one that I actually what shall we create now? Let's we used it before, but I'm still using it again because of the well, we still found new ways of dealing with it, let's say. And it's based on a real case also from one of our customers. Basically, the idea is to, in this EOS machine, put 200 copies of this one and have them nested in there. First nesting, well, of course, you get kind of piles, stacks of heat in this case that would be built up here, with of course a density graph that looks quite crazy, going up and down up to 36% here. So that's a bit of a challenge. Now, one thing that our part rotation does here, and I think that's quite important to know, is that it's not gonna randomly start rotating everything just like that. It's first going to check whether it encounters parts that are really like each other's mirror image. And then, of course, it's quite logical that in that case, you got a high chance that there's a lot less surface involved if you put them mirrored against each other. So if we try with that, and it does need some time, it's 200 parts in the end. It gives you, well, a lot, and we're now with a nesting height of 204 millimeter. We're gonna go see that down. Yeah, there we are. I'm stopping again at 99%. So at 146 millimeters. But of course, with a nesting density that in some cases up to 56%, you wouldn't want to dream of. Now, here there are really quite a few options. One that you could, for example, consider is say like, okay, no, I don't start with 200 parts, I start with 20 parts, and I'm going to start nesting those. And I'm going to give them a gap distance which is wide enough, because basically this first layer is causing my problem. That first layer is actually taking care of this huge percentage of density in one layer. So let's try and have a look at that one. This one already probably 45%, so that's pretty tough for some technologies. Now then we can just say like, okay, and I'm going to go to part view so that I can actually see what height I give it. I'm going to lock this one in position. So I'm going to select a couple of them and put them a bit higher so that I basically break this this equal density layer, let's say. And I should do a couple of more in order to come to a good spreading. Voila. But already you'll see, of course, that the density has gone down dramatically, 34% there as a maximum. So let's put a few more, perhaps. Oh, that's too high, probably. Uh, and now I'm not locking them anymore because just as well I can lock them all, and now see what the density says for 30%. So let's assume this is actually okay for now. And then, okay, how do I add the other 180? Well, I just import the part again. I make them 180 copies and I go nest again. And since the first layer is already a bit disrupted, you can, of course, understand that the other layers will also be more disrupted. So this very high peaks up to 56% will be gone in this way. That's just one possibility to go about it. And again, of course, I allowed the axis rotation, so it's taking a bit more time. Do you see here that, well, yes, we still have the 30% peak which I created in the beginning, which we could have done a bit less. But the next one is only about, what is it, 20, then 18, and then it's actually quite equal. So that was one way to go about it. Another way could be, I'm just going to now delete this, is by working with another part property is just by giving them a rotation. Of course, that will not be possible for all parts, because in some parts it will give marks in the printing lines, etc. So you might not want that. But that might actually also be an opportunity to decrease this density peaks in your density. Oh, again, I left the z-axis rotation on, so we're again waiting for a few seconds, but I dare to guess that it's still faster than many other solutions. Okay, so in this third case, again, just to say like, okay, we have a certain issue, we have a certain problem. We can't always go as high in density as we would actually want to. Then there are really different ways of looking at it. And it's your people who are actually working on this, who are actually doing this nesting, once they get the meaning of all the algorithms and the possibilities and how they interact with each other, it will take them just a couple of days, and they're better than us at this because they will do this on a daily basis, and for sure they will be better. So I think that's the main message of well, this actually comes out quite well without even touching this max layer density function. So that's another option. So that's the main message. You when you really give it a bit of attention and a bit of time to try and adjust and you iterate a bit, that's how you can come to nestings that not only have a better quality but have a higher density and really allow you to very quickly in just 10 or 15 minutes make batches that really are as you require them. Right, so far for the demos, and of course Chris took too much time again. That's the usual. Let's say my apologies for that, because what's coming next is at least as important, of course, because that's Ludwig from Phasio. Ludwig, yeah, I already explained how easy it was to start working this first batch with the CAMS pack, but it of course it came out of somewhere. So I think you can tell us where that came from and how that integrates with our solution, and then gets back to you. Let's say, are you sharing your screen?
Yes, awesome. Thank you very much for your presentation. It was super interesting. For me to be able to share, you need to unshare, and then I'll do that straight away. Awesome.
Thanks for mentioning that.
No worries. So, I'm Ludwig, one of the founding team members of Phasio, and we're a platform specifically developed together with also powder bed or jetting manufacturers to create an end-to-end workflow. And to be honest, it's never been really end-to-end. It only became end-to-end with the power of Amos nesting. And the reason that I'm saying that is that it is really about starting from your quotes through your order management, but then production, and you want to get all the information and the requirement setting that you have done with your clients and within your orders. You want to get them communicated to the nesting solution seamlessly, simply because there's a lot of source of potential human error. Maybe just like a little bit for this vision here, what we have at Phasio is we want to help local manufacturers to scale their operations, and that is shared along with Amos, of course, as well. And what you see here when I share my screen is a list of parts. And the reason I show this first is that you can understand the Phasio platform as basically a cloud of 3D models on steroids, because in all of these 3D models, you don't only actually save these, but if we take, for example, look at this queen here, this is just a model. You could make this in SLS and MJF and all sorts of technologies, right? And we look at the specifications, we see the ways that we have made this part before. So in this case, in MJF with vapor smoothing, and in MJF also without vapor smoothing. And what you can do within this platform is that you just click on the part and you add manufacturing constraints. And this here is the start of the connection towards the Amos solution, because you've seen Chris using his hotkeys, Alt Y and whatnot to really rotate the models, right? But when you print a model today and you have to print it in half a year again, there is no one really remembering how you printed it last time. And in order to really produce the same quality each and every time, which your customers also expect from you, you either have an extremely smart production management team, or people that are never sick or never on holiday, or you have a system that actually is able to store all manufacturing constraints on the part itself and to communicate that to your nesting solution, Amos, that can actually read those constraints. So I'll just, for simplicity's sake, add this constraint here. It's a fixed orientation constraint. And now let's take a look at how this is actually being used. So everything starts, of course, with a quote. I'll just add a new quote, have a few customers here, choose Phasio. And you can either choose to upload new parts or take parts from your library. So you could either take them from the customer parts, or as we did before, the queen here with our vapor smoothing, right? And I'll choose this part. I could choose multiple, right? And note that this doesn't need to be uploaded since it's there already. And then we'll just choose this 100 times, for example, right? When I add like a shipping option, for example, some self-collection, I get an automatically estimated dispatch date for this. And I'll create this this quote. However, I forgot to put recipients in. This one is for Harry and for the accounting team of that company. So I hit create. I get my quote here. I'll hit accept. Say the customer entered their PO 333. Hit accept here. And what you see is that there's a production tab appearing. And what that means is that every part in this order has attached its workflow. And that workflow goes all the way through vapor smoothing to completed, but it has here in the first workstation waiting for nesting. And that is obviously what this webinar is about. And we have prepared a little something already just to keep this short here. I'll move this order into send to production, and you can see that I have my 100 parts scheduled for production. And I'm leaving now the sort of like orders and quotes area and going into the production area, where I have the overview of all my workstations. And I see that there are 270 parts waiting for nesting. I can also see that there's already MGF build 2 at printing. So if I want to go ahead and take these parts, their defined orientations and their quantities and whatnot to Amos, I only have to press play here, and I get a set of powerful filters that I can choose. For example, I only want parts that visit vapor smoothing so that I don't have to organize the parts afterwards, for example, right? Or I choose a certain customer, or I work with due by dates. That is up to you. And I can go ahead and download these parts. I download them in the CAMSpec format, and I want the original CAD files. So in order to keep this crisp here, we have done this before, prepared this. So I would go ahead and download the CAMSpec file. Chris, as he showed already, he would open that file, of course, right? And then he'd do all his nesting tricks, keeping the z-axis free and all kind of stuff. And at the end, once it's nested, he can go and upload the bill of parts. So now the question is, which parts actually made it into the print, right? And you don't have to take care of that anymore because Amos is taking care of that, right? And Amos is exporting a 3MF file. And I'm just going ahead and importing that 3MF file here. And it will automatically create the build with all the parts that made it into the print. So this is the build that we created just now. And we could go ahead and upload another 3MF file and create build for build. But in this example, I'll just hit proceed here. And what you'll see is that there's another build in our printing. And this has only parts in there that have to be finished up until October 7th. That's all good. The October 1st one, that's less good. We're a bit late on this one, right? So you see that there are a couple play buttons, and the blue play button is to fast forward these builds. So I'd hit these fast forward and put that into post printing. Post printing could be anything. You can set this up in whichever way you want to, of course, right? This could be cooldown. And if I want to move these parts further in one by one, because I'm unpacking them from the print, I just press the green play button. I see there are just 2 parts in here. And I actually realized that in this gear here, there was something that didn't really work, right? So actually, like 10 of these parts, I have to set them to scrap. And I'll give it a reason. I'll say something like the gear was not clean or whatever, right? And I put a replacement in. I can replace 10, or maybe let's do 15 because I really need to get these parts out, right? Hit scrap here, and I see this is my scrap part. I could move over these parts as well if I wanted to, but this time I'll just scrap these. Hit proceed here. And these parts then automatically move back into waiting for nesting. So the next time that you download a ComSpec file and open that in Amos, these parts will immediately be there again, closing the loop on your feedback, basically. And we can also take a look into the order here, into the production tab, and you'll see that here's our gear wheel. And we want to understand what has happened here. You can always click and take a look at the production trace, and you see that there were 30 scheduled, progressed into printing, into post printing, and then there was the issue here. The gear was not clean, and hence we have rescheduled these parts just now. So if you wanted to see, oh, there was a problem and I want to get back to the same parts, you could always click on the build and you get back to the build which shows basically all the parts that were sent from Amos back to Phasio, which then concludes what I wanted to show. Really, this creates a seamless workflow connecting quotes all the way to production. And it's a significant reduction of human error because of the intelligent data handling in the background, especially then also by Amos, taken care of, such as wrong orientations. This could be a mistake, too few parts made. And it really creates a fast, simple, and also very smart nesting workflow that is scalable because of its ease of use. And yeah, thank you, Chris, for giving us the time to speak here.
Yeah, no, welcome. It's good that you can be here because indeed, I think we're indeed also looking for this kind of collaboration. And this build preparation is, of course, important. It's the most vital thing in the world, obviously, but it's part of a process. And I think, yeah, making sure that it fits inside that process is I think, important for everybody who's today also attending this webinar, but also the ones who are not probably. So thanks for sharing that. It's definitely part of how we want to approach that market, how we want to help that market at being more successful, really. Okay, right. Yeah, well, there we are. I hope. So thanks again for sharing that. We'll continue now a little bit. Mainly rounding up, mainly looking forward still to your questions, but I understand there haven't been many up to now. We'll look into it soon enough. We do, of course, still have some upcoming features as well. Actually, by fall next already, there will be our version 3 coming out. which will have the main new features which you see listed here. Some of them, which with the asterisk, are actually already being tested as we speak. So some selected trial users might be able to already experience that in the coming day. And the other ones is so the adjustable hole and strut sizes. That's actually being tested as we speak. Duplication of parts is also being tested. An improved output tab, which is now the still called slicing tab. Conformal boxing, a bit similar to what you see here, is coming up. So there's still a lot of things coming up. Definitely also aimed at the SLS users, with, for example, an SLI and CLI export, and the Z direction compensation. So that's going to be our version 3, but nevertheless, even let's say without those extra tools, our current users are choosing for AMIS Pro because of the tools it has, not because of the tools it's going to have. And it really already allows them to just do what is needed there. I'll promise to say something on the pricing as well. Nothing has changed there. It's either 499 or 399 per license per month. That's an individual license. And the one is for the monthly license. The other one is for an annual license. Of course, if you take multiple licenses or multi-year, multi-seats, there are some discounts that can be applied. Please do contact us. And also, if you're looking at more more cooperation in case that you're a printer OEM or you're looking at developing something together, that's something we can discuss about one-on-one, of course. So that brings us to the next session. Next part of the session. I'm sorry. Adinda, do we have any questions actually?
There is a participant who's asking whether they'll get a recording of the webinar.
Yes, it will be made available tomorrow or on Monday, but depending on the availability of the people working on that. Thank you.
And then there's also another interesting question. One of the participants, are you thinking about smart nesting over multiple builds?
That's a very yes, that's a very interesting question indeed. And it's definitely something we want to look into. Now, that is really such a case where I don't believe that we should be making something out of thin air, some castle in the sky. So that's something we should do based on real examples, I think. So it's definitely, we would love to start talking about together with you, because the smart division of the parts over the different builds, that's going to be the biggest algorithm to solve, so to say. So let us look into it, because there's an increasing demand for it. So we're definitely willing to start working on that as well. I would love to start that discussion.
Very interesting also in combination with the Phasio tool, where you sometimes have thousands of parts in the backlog. And if then Amos was aware of all of these, you could feasibly also predict how many builds are in there, and then do a bit of your planning.
Yeah, indeed. Well, we have to set up another meeting as well then. Right.
If there are no further questions, then maybe it might be interesting to also get a quick recap of the takeaways still.
Yes, but I think people have got the message by now. I hope.
Okay, we'll
No.
presentation.
Yes.
And then maybe to close, thanks first of all for the speakers. Thank you so much. It was very insightful, and also for everybody that was listening. If you have any questions later on, we're always available via email. And then maybe just to close off, where can you find us in the upcoming months? We'll be at Formnext this November, and we'll also in December be or Chris will be doing a tour of duty in Paris. So talk to a few people over there. And then there's also there's also Rapid TCT in April. If you are interested in a trial license or you're interested in staying up to date, you can always contact us via our website. Equally so for our friends at Phasio. And so, yeah, I think that for now, I think that we want to thank everybody for listening, and yeah, we hope to hear from you.
Yes, indeed. Thanks a lot for attending. We look forward to hearing from you, and we'll get this recording ready for you as soon as possible. Thanks again.
Thank you.
Bye.